Well, welcome back to the attic. Today I'm playing around with a module. It's a BTS7960. There's two of those chips and a HC244 driver for them. And this is the inputs you have. You got PWM, you got enable. This is an output. And of course your ground and power. The low side is 7 milliohms. It's a N MOSFET, and the high side is a P MOSFET, and that's about 9 milliohms. And that's 5 times better than one of these solid state relays that I've been testing. So I thought this would be kind of an interesting thing. You know, if you have something that you want to drive, these are good up to 45 volts, and they say 43 amps. You know, I wouldn't want to do that continuous, but yeah, at least get 20 amps out of it, and that would outperform one of these solid state relays. And you get two drivers. They're independent, and they're comes with a heat sink, and they're only about $10. So I thought, let's turn one of these things into a water heater. So it turns out that the output, when you disable the enable, so if you let enable be low, it's just a floating output, you know, like an open collector. But if you power enable, then what happens is set enable high, and the output turns on. You know, that's kind of neat. So it's really a very simple driver, all in a package. And like I say, you only need one input. Now you could set PWM high, and then when you enabled it, then you'd have a high side driver. But low side drivers are always lower resistance because PMOS FETs suck. So yeah, I've supplied a little bit of power here. The two power pins, I put a 5.1 Zener on them. 2K resistor to your B plus here. So this is all self-powered now. So what you do is it's got a 10K pull down on this input. So I just got a 50K ohm from 5 volts down to this enable line, and I got a capacitor on it to stabilize it again. So let's play around with this. Let's turn up the voltage a little bit. Climbing. And it turns on about 2.5 volts. A little instability there. And this just doesn't seem to have much hysteresis to it. But these things can operate up to 25 kilohertz, so yeah, let it oscillate a little bit. But you could easily have a pot going up to your solar panel, and you could put a Zener in there to subtract some of the voltage to sort of amplify the changes. And then you have a water heater. Oh! Cloud passed over and my inverter just died. It's totally solar powered, no batteries or anything like that. And it's the afternoon, and it's kind of cloudy. There's been some rumbles of thunder. It's going to rain. But that's the interesting thing about this. I'm going to do up a water heater with it. A lot of camp systems are low voltage, so this would be a chance for someone to get hot water, and this could tie right onto their existing MPPT charge controller, not use any battery resources, and they'd have hot water for $10.